Chemical engineering is a very broad degree and it consists of many different technical subdisciplines. There is no one big subject called chemical engineering, but during your degree you will study a variety of different technical subjects which will focus on a different aspect of engineering. So in this video, we have decided to have a look at some of the technical courses which you can be expected to study during your degree. So do remember to watch the video till the very end, and if you do like it, then remember to like, share and subscribe to ChemEnggLife for more videos. Thank you. If you have ever been inside a factory, you may have seen that there are these big pipes that are bringing these raw materials into these huge equipments, and on the other side of these equipments are new products coming out. So within those equipments, something must be happening, right? Which is either physically or chemically changing the incoming feed into the product that you see on the other side. These processes could be anything from mixing, separation, crystallization, distillation, and the list goes on and on. In chemical engineering, we call these steps unit operations. So of course, just like how chemists perform their experiments within lab environments with their white coats and goggles, chemical engineers have their lab courses within unit operations while they're wearing their hard hats. Typically, every chemical engineering department has a pilot plant set up in a small scale where you can go and perform these unit operation experiments and play around with different variables and flows and learn how it affects the results. Hands down, the best class in your degree because this is the only subject where you will get a hands-on, first-hand experience on how chemical engineering is applied in a real-life situation. Another technical subject is Plantwide Control. In this subject, you will learn about combining and integrating process design with process control principles. You will have a basic class in process control, but that will be a class where you will learn about the basic principles of maintaining key processes in a manufacturing process. Whereas in plant-wide control, you will learn how you can implement those theories onto a full-fledged process design and diagram. Think of it this way. You learn simple arithmetic in one class, like adding numbers, subtracting numbers, and so on, and then your teacher sends you to count the number of actual apples in a retail store. So process control is your simple arithmetic class, while plant-wide control would be you applying arithmetics to counting the apples in an actual store. It may sound like an exaggeration, but it is very true, because a chemical plant may have more than hundreds of measurements and control loops, and those variables and loops are not provided to you on a silver platter. Therefore, as a control engineer, when you're given the process design and a process diagram, you need to be able to answer many questions such as which variables are important to be controlled, which and how variables can be measured, and in the case of any deviation, how can you change the inputs? And these are only some of the questions that you will need to be able to answer, and this is something that you will learn how to do in this course. Another technical subject is transport processes, sometimes also called transport phenomena. In this subject, you will be taught about the modeling and the numerical description of flow, heat, and mass transport. In this subject, you will get the advanced theory and examples within fluid mechanics and heat transfer. Within chemical engineering, you may expect to have these chapters focused entirely on chemical engineering examples, where you will focus entirely on process engineering problems. But it is a very intensive and a difficult subject with a very high level of mathematics. And you know how many people joke about mathematics not having enough numbers? Well, this is definitely one of those courses where you will be strictly working with modeling and differential equations. You may even be expected to simulate your models using programs such as COMSOL and write multiple reports. And out of all the courses within chemical engineering, this one tends to have the highest amount of workload and is considered to be one of the most difficult courses that you will study as a student. Mathematics is the language of engineering, and as a chemical engineer, you need to be able to translate real-life situations into mathematical language. In engineering terms, a mathematical model is a set of equations which describe the behavior of a real system and tells you how the behavior of the system may be influenced by external stimuli. These mathematical models are very important for engineers because by the help of these models, engineers can design and optimize different processes. In this subject, you will learn exactly how to do that. And this is the subject where you will learn the famous chemical engineering material balance, which states in minus out plus generation minus consumption is equal to accumulation. This model helps you explore the connection between chemical reactions and the transport phenomena in any production environment. And don't make the mistake of thinking that it is a simple equation, because it is not. It may sound very simple, but it quickly turns into a complex equation of differential equations and integrals. And this is a compulsory subject for chemical engineers, and you can expect this to be one of the very first technical subjects which you will study in your degree. Another technical subject is model analysis. This is a subject which can actually be considered to be an extension of your mathematical modeling classes. For engineers, it is not only important for them to be able to write mathematical models, but they also need to be able to solve those models either analytically or using approximate methods. And that tends to be the focus of a course like this. This can be considered to be a more programming-oriented course for the development of models and for carrying out numerical solutions. And you can expect to work extensively with programs such as MATLAB and Maple in order to solve your models. And thank you so very much for watching. And if you feel that we missed out on a subject, then do remember to tell us in the comments below. And if you have not done so already, then do visit us at www.ChemEnggLife.com and become a free member today. And also do not forget to like, share, and subscribe to Chemical Engineering Live channel for more videos on chemical engineering. Thank you and have a great day.